Okay, so welcome to this video. So today we're gonna see how to set up a fuzzing target and implement fuzzing using cargo-fuzz on a popular Rust library. So the main goal will be to show you that in really like in less than 5 minutes you are able to set up a fuzzing target. So that's kind of pretty interesting. So first of all, we need to select a target. So for that I have been into crates.io. I select the type parser. It's the parsing, everything regarding like parsing library are one of the most easiest target to fuzz. So that's why we're gonna start with this one. So there is a bunch of them. I choose to select a humantime. So it's a parser for the time and duration format. So that's something that is well used. We can see that with the number of download all time, and as you can see there is a bunch of them. Then you can take a look directly to the documentation. So we have the documentation of the Rust library right there, and we will need, since we're going to use cargo-fuzz or libFuzzer for Rust if you prefer, we're going to need the GitHub of this project. So that's the GitHub of the project, and for cargo-fuzz is this one. So we will need to install cargo-fuzz. So you have the command line right there, and I actually already done that right there. So I already cloned the repository, but I'm gonna show you directly step by step. So the first step is to do a git clone. So let me just create a basic repository. So this one, we're gonna then do a git clone. So let's first install. We're gonna do everything together. Cargo install. We're gonna use the nightly version of the compiler. So cargo nightly install cargo-fuzz. It will already been installed. As you can see, it's already done for me. So then we're gonna clone the humantime repository. So humantime. So we're gonna do a git clone humantime. So let me just open that a bit bigger, where we have the humantime repository right there. So we can go inside this one, and as you can see, there is no fuzz folder. So that means there is nothing, there is no like fuzzing target already implemented for this package. So we're gonna initialize the fuzzing folder for cargo-fuzz. So we will need to do cargo-fuzz init. So right now we can see that we have a fuzz folder, so we can move on. Okay, so let's let me just show you right there. So we are on the test. This one is the one that contain everything that is already done. So let's do first together. We have the first folder, and as you can see, some folder and cargo toml have been created, and we have a first target. So if we click on this one, we can see that it's like the minimal template of cargo-fuzz. So that's something that is interesting for us, and we're gonna put some code right there. And we have the cargo toml, and we have the definition, like the definition of the binary that is right there. We're gonna keep that like that for the moment. It doesn't really matter. So what we will need to do next is to find some interesting methods to fuzz. So for humantime, if you take a look at the documentation right there, you can see that there is three methods for parsing: parse duration, parse RFC 3339 and 3339 week. So that's this one, and as you can see, the method is pretty simple to use. You just need to provide a string. So for cargo-fuzz, you will right there, we will provide an array of a U8. So in that case, let me just move that. In that case, we will need to convert this U8 into a string and provide that to the method we want to fuzz. So we're gonna first start with the parse duration. That is really simple. So we can just, in that case, we already have access to human time since we have a path dot. So we're gonna just say okay, use this one, so use, okay, and we're gonna fuzz this one, but later. First we're gonna convert this data, this array, into a string. In order to do that, we're gonna do if let okay. So if we succeed to convert this array into a string, after that we will need to use std, don't remember, let me check, I don't remember the syntax by head. Yeah, std string, so like that. Let me just copy that. So that's what we're gonna do. We're gonna convert this array into a string. It will be s if it's okay, and we're gonna provide this s to parse duration. Okay, and that's all. It's all we need. After that, we can directly run the fuzzer. So let me do that. We are right there, and we can do first of all cargo-fuzz list. It will list the available targets of cargo-fuzz. So we have one target right there. That's the one we create, and we can run the fuzzer by using cargo-fuzz run fuzz target. You don't forget to provide the flag to tell to cargo that we're gonna use the nightly toolchain, and you can see that he will compile human time with libFuzzer-rs. So it's because cargo-fuzz is using libFuzzer internally. It's the libFuzzer binding right there. So you're gonna compile everything, and after that you're gonna directly start the fuzzing. So as you can see, we have some stuff, we have some coverage information, we have some execution speed right there, and we can see that it's pretty fast, and yeah, it's just continued and so on and so on. So it's kind of complicated for him to go even deeper, but I think it's mainly because the method is really tiny, and actually we are not providing any corpora, any input files to the fuzzing. So so that's pretty much all for this one. So if we want, we can do exactly the same. So as you can see, in less than 5 minutes we was able to do fuzzing on this specific target, and potentially find some bugs. So in that case, no, but actually we don't know. We will need to, if we really want to go deeper, you will need to take a look at the coverage and see which part of the code have not been reached by the fuzzer and so on, add some corpora and so on. So let me show you what I've done for the other function. So it's on this folder that will be provided right on the link below. And we have fuzz targets, and as you can see, I create a parse duration, parse RFC week, and even if you don't want to run like 3 different fuzzer, you can just run one. The main issue with that is you will lost some speed, and I mean you will lost some execution time, because you will provide some what you are providing to parse duration will not be the same than what you are providing to RFC 33-39 week. So it will execute this stuff and maybe reject it when it will be actually a valid RFC, this one. So doesn't really matter. I mean, for the example, you can just do that, and it will be largely enough. So let me show you after like 5 minutes what was the result. So I was cargo-fuzz list. Let's run all, and yeah, I forget the nightly flag. Nightly. So as you can see, after some time we get a bit more coverage, and so on. There is some reduce, some optimization. I mean, libFuzzer is handling almost everything by himself, and so on. So we will continue to fuzz. As you can see, the speed is pretty fast. I'm running on AMD 3700 or 600X, something like that. So something with 16 core. I'm pretty sure it's using only one core, but the library is pretty short and not containing a lot of code, so that's mainly why. So what you can do to improve your fuzzing will be first adding some extra corpora. So in that case, you will add some stuff into, so let me go into the fuzz folder, and right there you have the corpus folder. So on the corpus folder you have some additional folder, so for the whole, and as you can see there is a bunch of stuff inside it, so that's everything that have been generated automatically. So let's do a cat in order to see what exactly it looked like, and we'll get an idea. Okay, that was one string provided by and generated by the fuzzer, and let's do this one. Okay, so as you can see, without specifying anything to the fuzzer, he was able to determine that minute was something interesting for this specific library, and so on. So that's for the corpus. If there is any crashes, the libFuzzer, the cargofuzz, will completely stop, and you will get the crashing sample directly stored into artifact. So as you can see right there, I have nothing, so that's mainly why we have not seen any crashes. We have the first target, so that's all the piece of code we have done, and we have target, that is all the compiled binary. Okay, so that's pretty much all. As you can see, it's really short, really tiny, really it's not so complicated. There is a bunch of stuff that you can do with libFuzzer, like structural fuzzing and so on. If you want to learn more about Rust fuzzing and Rust security audit in general, you can check the link in description. It's my 2-day training. It's like a training of 9.5 hours. Really, we are really going in deep into Rust audit and fuzzing. So if you're interested, you can just take a look. Thank you.